So in this example, we're going to find a pivotal quantity based on a random sample size of n, that comes from a normal distribution from theta to theta from a population where our theta is greater than 0. So to do this, we're going to use the pivotal quantity to set up a 1 minus alpha confidence interval for theta. So to do this, we're going to need to consider it from x1 all the way to xn. And this needs to be an IID, again from the distribution, normal distribution from theta to theta. If our x bar is our sample mean from this pivotal quantity, that means, with the parameter of theta, that means our t will equal this. And this is what it looks like simplified. And because of what we have here for our t is also going to come up from a normal distribution, because we have a normal distribution there. And it's going from 0 to 1. This is just because theta has to be greater than 0, but it can't be larger than 1 in this case because we have that 1 minus alpha. So if we're going to look at our lower and our upper bounds, we'll call it L of theta and U of theta. We're trying to see what it would be for 1 minus alpha. So it's going to look something like this for our lower and our upper bound. Because by just definition of lower and upper bound, it has to be between, our t cannot be greater than u for upper bound, and it can't be less than our L. But we know actually what t is, so we can go ahead and just plug that in right here. And just like the other example, we get our confidence interval the same way. Thus, our lower bound is between, and our upper bound, and our t is in between it. So to move on, since there's a square root, let's go ahead and get rid of the square root. To do that, we do the opposite, which is to square it. So we're going to square literally everything so we can get rid of that square root right here. So then it will look like this. Again, let's go ahead and see if we can simplify this anymore. I see that for my t, I still have that denominator, theta divided by n, so let's see if I can simplify that a little bit. And to help get rid of the n, it actually just moves up here when you flip it, because, multiply, keep, change, flip for fractions. Therefore, it will go from here to there. Thus, when rewriting and simplifying it, right now, this is what we have. Normally, we try to make everything as simply as possible, so we see that we have the theta still on the bottom, so we're going to go ahead and get rid of it using our basic algebra skills. So we multiply by theta with everything. And we now have this. For this inequality right now, we're just going to look on the inside stuff to see how we can even simplify this and make it a little bit more easier to understand. Because it's an inequality and it's the same on both sides except for the minus, we can actually go ahead and rewrite it. Now that we have this, we can see that since there's a squared here, it is quadratic. And we want to get we want to see if we can simplify it even more. Since there's clearly an n, we're going to go ahead and divide both sides by n. That way it cancels on one side. Since we have a square right here and it's a quadratic, we can go ahead and actually just FOIL it. Thus we get this. So we're going to actually, since we have a divide by n, we're going to do the opposite, which is to multiply by n, so it will cancel out on the side. Thus, when simplified, we get this. Then we're going to subtract our theta z. That way it cancels on this side, and I get a 0, which is always what we want when we're trying to solve for a quadratic kind of equation. And since there's a lot of thetas, we're just going to reorganize so we can see that there's obviously something in common in this case for a lot of things, theta. So we can go ahead and take a theta out of what they do have in common. But when looking at all the thetas and stuff, I could actually see that there was a pattern, and it looks kind of like a quadratic because there's square on the x's bar and the thetas, so I rearranged it this way. We can actually use the quadratic formula because we can, if we imagine our theta squared as our x squared, then we have our ax squared plus bx plus c. So we can actually use and try to solve to see what our theta would be using our quadratic formula. I also forgot to explain the reason why the front part of here, like the 2 in x bar is positive is because right up here we have the negative, and a negative makes a positive. And we can simplify this. And to get it simplified this far, all I did was take that part right up here with the square, this part right here, sorry, with the square, and I FOILed it out. If you look, there's some things that are opposite that will cancel, and then we can simplify what is left. Therefore, we get this as my answer so far. Therefore, my theta is this, and that is my pivotal quantity of theta.